These two possibilities exist. Either we are alone in the universe, or we are not alone in the universe. Both possibilities are equally frightening. Arthur gets bored and subscribes. I have a question for you. Are there more stars in the universe or all the grains of sand on Earth? Isn't it difficult to answer without hesitation? Yes, we know there are a lot of stars in the universe, but each grain of sand on Earth doesn't add up to a significant number, does it? If you had stayed, you would have made this comparison on the television program Cosmos. According to the studies of geologists and geographers, the number of stars in the universe is greater than the grains of sand on Earth. According to calculations, the number of stars in the universe is more than 4 sextillion. Our perception begins to become vague after the units of million and billion. When we start talking about numbers like septillion, opti, leon, mobileon, my head turns into steel wool. That's why, in order to understand how big the universe is, we will use visuals and animations along with numbers. This way, we can understand the size much better. We start from the scale of a human on our planet, on Earth. We set out from a distance of 1 meter. At 100 meters, we can see the Google building. At 10 kilometers, we begin to see settlements and mountains. At 100 kilometers, we see San Francisco Bay. At 1,000 kilometers, we see Western America. At 10,000 kilometers, we can now see our planet from the outside. At 100,000 kilometers, we see the Earth and Moon at 1,000,000 kilometers. The lunar orbit is 10 million kilometers closer to Earth. At 100 million kilometers, we begin to see the inner planets. At 1 billion kilometers, we see the other planets. At 10 billion kilometers, the Kuiper Belt. At 100 billion kilometers, the dwarf planets. At a distance of 1 trillion kilometers, the inner parts of the Oort cloud. At 10 light years, we begin to see their outer parts. At 100 light years, we can now see neighboring stars like Alpha Centauri and Sirius. At 100 light years, we have reached a size called the local group. We are passing the Orion Nebula inside the bubble. At 10,000 light years, the spiral arms of our galaxy begin to appear. At a distance of 101,000 light years, we can now see the Milky Way galaxy. At a distance of 1 million light years, neighboring galaxies are 10 million light years away. We are in the local galaxy group, which includes some other galaxies. The local supercluster is 100 million light years away, and at a distance of 1 billion light years, it is a cosmic AA. After this distance, we can no longer see anything but the cosmic man. For now, this is the farthest place we can go. This is a cosmic AA that contains an incredible number of stars and galaxies. According to most scientists and widespread theories, we are one of the countless universes floating in this sea of an infinite universe outside this cosmic web. We have gone too far. Let's go home. So let's go back home. We have traveled in such a vast universe, but during our journey, we have not seen a neighboring civilization nor any living life. According to statistical calculations, shouldn't there be thousands of millions of living beings around us that are suitable for life? Really, where are they? Or has something else changed? Where is everyone? This question is one of the biggest moneymakers in human history, known as the Fermi Paradox. The Fermi Paradox is the inconsistency between the high probability of extraterrestrial life and the lack of any evidence or contact to confirm it. In fact, this is a simple question we all ask or can ask everyone. You may hear that even a friend of yours might come up and say, if there are aliens, why haven't they come? Or why aren't there any traces of them? However, when the famous physicist Enrico Fermi said this, it was accepted as a paradox. He is about 13 billion years old. The universe has been expanding rapidly since the Big Bang. There are countless stars, planets, and galaxies in the universe. Assuming that Earth is an ordinary planet, the probability of living beings living on other planets in the universe is quite high. The real problem is, why can't I prove this? Or why can't we find any traces of it? The size and age of the universe suggests that there should be many technologically advanced civilizations. However, this hypothesis is inconsistent due to the lack of observable data to support it. Enrico Fermi, discussing this issue in 1950, said, if there are a large number of advanced civilizations on Earth within the Milky Way, we don't find any evidence of alien spacecraft or probes on this stage. Michael Hart's article on this subject in 1975 started the discussions. This paradox is also called the zipper paradox. Another question related to this issue is this silence. The great silence. Even if space travel is difficult, if extraterrestrial life exists, shouldn't we at least hear radio signals from these civilizations? Meanwhile, there are also views that this paradox doesn't belong to Fermi, or even that it's not a paradox at all. Physicists interpret Fermi's alleged statement, "Where is everyone?" to his fellow physicists at lunch in different ways. When the subject of extraterrestrial life is discussed, two different thought structures are generally encountered. One of these is the Drake equation, which calculates the number of civilizations on our island that can detect signals. The other is the Fermi Paradox, which considers research unnecessary by saying that if there were intelligent life, they would have already developed a colony in the sky. The Drake equation was developed by Frank Drake. Original information about the Fermi Paradox is submitted. It is said that God has not had the patience of the physicist Enrico Fermi, after whom it is named. In both cases, let's continue pursuing this question. While we're at it, let's talk about the color equation. The Drake equation is an equation used to calculate the number of intelligent civilizations in the Milky Way galaxy. It is important in the search for extraterrestrial life. It was first proposed by Frank Drake, a radio astronomer, in 19... This equation is a Drake equation. Although known as the equation, scientists like John and Toastju have contributed to the formation of the equation. The equation is as follows: what is the number of civilizations with which we can communicate? The annual rate of star formation in our galaxy. How many of these stars have planets? The average number of habitable planets per star. The number of planets among these planets that have a suitable environment for life in any way. How many of these habitable planets have created this type of civilization? The fraction that can leave a detectable signal in space regarding their existence. The duration of the detectable signal emitted by such a civilization in space. It is estimated that there are 10,000 intelligent civilizations in our galaxy based on their colors. In addition to their colors, a scale of possible civilizations has been constructed using the Kardashev Scale. The Kardashev Scale is a method that measures the technological development of civilizations according to the amount of energy they can use to communicate. In 1964, Russian astrophysicist Nikolai Kardashev, who did not live in extraterrestrial intelligence via cosmic signals, emphasized the idea that the civilization status of a culture is generally based on two basic things. He proposed that energy and technology are based on the principle that a civilization's technical development parallels the amount of energy it can use and manage. This means that the more energy a society can produce, the more technologically advanced it becomes. Initially, this idea was based solely on the energy available for communication. However, it has since been developed and expanded. In other words, according to this theory, the development of a culture is, in its most general sense, the product of energy and technology. Energy is obtained through technology, and social systems are based on this technology. The status of a cell culture is based on the amount of energy used. This scale has a number of different classification levels. Each is based on a level of energy consumption. Type A, Type 2, and Type 3 are other. Astronomers have expanded the scale to Type 4 and Type 5. These additions consider the amount of information on which civilizations can develop, as well as their access to energy. In short, in recent years, scientists have expanded this scale to hypothetical civilizations, galactic, intergalactic, and multicultural civilizations. Now, let's take a quick look at these civilization types. Type 0 Coat. The universe's culture is this. Civilization extracts its energy and raw materials from organic-based sources such as wood, coal, or other such. Any rocket used by a civilization would necessarily rely on a chemical history system. Because this type of travel would be extremely slow, a civilization at this level would be largely confined to its own planet. A type of planetary culture would be slightly more advanced than those currently on Earth. They would be able to expertly harness the full energy output of their planet. This civilization is thousands of years more advanced than ours. Such a society would be able to harvest, store, and use the energy of its star to meet the energy demands of a growing population. This would mean increasing our current energy production by a factor of 100,000 to achieve this status. However, being able to harness the energy of the entire world would also mean controlling all natural forces. Humans could control volcanoes, weather, and even earthquakes. While it is difficult to believe such capabilities are attainable, these are simple and primitive levels compared to later types. A Type 2 interstellar culture would allow this civilization to harness the power of all stars. It could not only convert starlight into energy, but also control the star itself. The most popular proposed method for this scenario is the Dyson sphere. This device would cover every inch of the star, collecting most of its energy output and storing it on a planet for later use. Alternatively, the star's fusion power could be transferred by this civilization as a large-scale actor. A Type 3 galaxy culture could be used to meet its needs. Traveling from this planet to a controlled star would contain sufficient expendable energy to render the civilization immune to extinction. However, after this type has acquired all kinds of energy information and advanced its civilization to a galactic level, it transitions to Type C and becomes the main 40. This civilization can use the energy output of a galaxy. It is approximately 10 billion times the energy output of a Type 2 civilization and is approximately 100 to 1 million years more advanced than us. They can colonize the galaxy. They can extract energy from hundreds of millions of stars and travel through interstellar space, conquering countless planets. For humans, such access would mean hundreds of thousands of years of evolution, both biologically and mechanically. In other words, a different transformation than the human race as we know it could have occurred. These could be cybele or cybernetic organisms that can be both biological and robotic. In other words, the descendants of ordinary humans would be a subspecies among highly developed societies today. Purely biological humans. Perhaps their cybernetic friends would see them as flawed, inferior, or intermarrying with their own sibling. Because it would be so advanced in its scaling, it defined a beyond for Type 3. However, later names like Michio Kaku, Robert Dublin, and Kardashev also defined a Type 4 universal culture. This civilization would be an intergalactic culture encompassing the universe. They could travel the universe by commanding the power of trillions of stars. These societies would possess superhuman abilities, such as altering the structure of space-time to achieve ultimate immortality, or deliberately slowing or reversing entropy. These civilizations would become viable within the event horizons of supermassive black holes. For current humanity, such things seem far beyond our reach. Type 5 multicultural culture. This civilization would have opened its own universe. It would possess the ability to manipulate the scale of the universe. Such a civilization could possess unimaginable powers and abilities, such as jumping between multiple dimensions involving matter, physics, and space-time, and 12 forms. So, where does humanity currently stand on these scales? Unfortunately, humanity currently doesn't exist on any of these scales. We can roughly say it's slightly below Type 0. We still use dead animals and plants as energy sources, and we still rely on nature for energy. According to Michio Kaku, it would take 100 to 200 years for us to even reach the type. The fact that we still haven't even reached the type is a bit disturbing. Similarly, if we want to go beyond the Type 0 civilization, we could easily return to the Stone Age due to natural disasters or a disaster caused by our own actions. My first step is to protect our small universe, end wars, and continue to support scientific developments and discoveries. By the way, speaking of extraterrestrial civilizations, I want to briefly mention this here. We've been working on a great documentary for a long time on our game review channel, The Machine. The documentary tells the story of what the combined culture, a level V civilization that has managed to dominate the universe, can do to humanity and nature when it comes to Earth. If you watch the upcoming Half-Life documentary, Unforeseen Consequences, you'll hear a great science fiction story. If you want to watch this documentary, you can follow our Machine channel. Now let's get back to our topic. As a refresher, the observable universe is approximately 90 billion light-years across. There are at least 100 billion galaxies in the universe, each weighing 1 trillion and 100 billion. The universe is home to probably trillions upon trillions of habitable planets. In short, there are many possibilities for life to exist and evolve in the universe. Isn't that so? Where is this life? Or, as we said at the beginning, what is this? Even if extraterrestrial life exists in other galaxies, there seems to be no way to reach them. If you remember at the beginning of the video, I mentioned the local group scale. As we approach the boundaries of the observable universe, we may never reach anything outside this local group. Actually, there's a simple reason for this: the expansion of the universe. Even if we were traveling close to the speed of light, it would take billions of years to reach stars outside the local group. By the time we leave Earth and leave the local group, the universe will have already expanded enough to leave us on an endless journey through empty regions of space. Okay, let's forget about the universe outside the local group. For now, let's just focus on our own Milky Way galaxy. There are approximately 400 billion stars in the Milky Way galaxy, 20 billion sun-like stars. According to estimates, 1/5 of those stars have an Earth-sized planet within the safe habitable zone. In other words, only 100% of these planets are necessary for life to form and possess them. Even if there were life in 0.1% of the Milky Way, there would be over 1 million planets teeming with life. However, we haven't found any traces of it. There's no definitive answer to this paradox, but there's a widespread theory, the Great Filter. Some theorists accept that the absence of evidence proves that extraterrestrial life doesn't exist and attempt to explain why. Other theorists propose ideas about the behavior and technological level of extraterrestrial life to explain the Great Silence without excluding the existence of such life. In fact, each of these prosthetics would mean changing the value of one or more factors of the break equation. These theories are generally not mutually exclusive. For example, the hypothesis that life is rare and the hypothesis that technologically advanced civilizations are prone to self-destruction could both be true simultaneously. According to the Great Filter theory, let's consider our best predictions for an evolutionary path that would lead to an explosion that would lead to the visible colonization of large parts of the observable universe. The star system is something that enables reproduction. Simple single-celled life, complex single-celled life, sexual reproduction, multicellular life, large-brained animals that use manipulative methods. The Great Silence that erupts into the picture of our current location and colony means that one or more of these steps is extremely unlikely. There is a large filter on the path between simple inanimate matter and exploding life. In fact, among the billions of trillions of stars in our past universe, nothing has ever made it all the way through. The fact that our universe is apparently fundamentally inanimate indicates that it is very, very difficult for advanced life to emerge that can sustain itself. Furthermore, if there are radically different paths to pervasive permanent life, this only exacerbates the problem, as it means the filter on our path must be even larger. One explanation is that human civilization is unique in the galaxy. Parallel to this idea, many theories have been proposed as to why intelligent life must be so rare or short-lived. Many explanations have been developed under the heading of the Great Filter. Let's look at some of these explanations together. No other civilization has ever emerged. According to those who believe that extraterrestrial life does not exist, the conditions necessary for the development of life, or at least complex life forms, occur very rarely. In fact, this situation is unique to Earth. This view is called the rare Earth prosthesis. This hypothesis, those who defend the principle of mediocrity reject the principle of mediocrity and attempt to resolve the Fermi Paradox by arguing that the unique Earth concept has received support from philosophy and religion in the past. But the rare Earth prosthesis offers measurable and statistical arguments suggesting that multicellular life is extremely rare in the universe because Earth-like planets are already quite rare, or that an extraordinary series of coincidences have combined to allow complex life on Earth. Intelligent life inherently destroys itself. It is likely that technological civilizations will generally or always destroy themselves immediately before or after developing radio or space travel technology. The cause of extinction could be nuclear war, biological warfare, or accidentally transmitted diseases, nanotechnological destruction, mismanaged physics experiments, a poorly programmed artificial superintelligence, or a Maltose disaster resulting from the deterioration of the planet's concert. Intelligent life inherently destroys others. Another possibility is that intelligent species above a certain technological capacity will destroy other intelligent civilizations as soon as they find them. The basic themes related to science. It has been frequently discussed in scientific literature as well as fiction. A species may attempt such destruction for expansionist purposes, either for money or because of its aggressive nature. They exist, but we cannot find evidence. Even if there are technological extraterrestrial civilizations, humans can communicate with these civilizations due to various filters. The scale or technology issues are in a way that we cannot understand due to the nature of the aliens. Some of these reasons could be the time required for humanity to search for extraterrestrial life or humanity's refusal to see the evidence that exists. Humanity has not been searching for extraterrestrial life long enough for it to be found by others. It's also possible that humanity's ability to find and communicate with extraterrestrial intelligent life is short. If the discovery of the radio telescope is considered a milestone in this regard, it has been around since Furthermore, Homo sapiens is a very new species on the geological scale. The entire span of human existence, approximately 200,000 years, is a relatively short time on the cosmological scale, while radio transmissions have only been made since 8. Therefore, humanity has neither explored another civilization long enough to discover it, nor has it existed long enough to be discovered by other civilizations. Physical expansion throughout the galaxy is very expensive. It's possible that the feasibility and cost of interstellar colonization cannot be fully calculated within current scientific knowledge. Ununderstood theoretical obstacles to such an endeavor may arise later, or the material and energy costs may be so high that no civilization could exist. Aliens are a technological singularity. Another possibility is that technological civilizations are invariably in a state of technological singularity and must exhibit a transhuman character. Such theoretical civilizations consist of individuals who have changed to the point that humans cannot communicate. Communication with these civilizations, which have passed beyond the singularity, will require much more information exchange than can be achieved at interstellar distances. They will find any information humanity can provide to the center so simple that they will decide it is not worth communicating. This situation is similar to humans trying to communicate with ants. They may prefer to communicate with us. The zoo hypothesis, the belief that aliens would want to communicate with humankind, may be a fallacy. Even if aliens are technically capable of communication, they may prefer to communicate with humans. One possible reason for this is called the zoo hypothesis. The world could be an isolated zoo or wilderness environment, constantly monitored by aliens. They are not technologically intelligent. It is unclear whether this civilization must necessarily be technologically advanced. An alien species may have chosen to develop technology because the conditions in its environment were not suitable, or for some other reason. In this case, the discovery of such a civilization by humanity would be very difficult. It is best left to the last. I hid the simulation theory. We may be living in a simulation. If this is the case, other living life forms may not have been included in the simulation, or our communication with them may have been restricted. Intelligent life forms have been included in the simulation at the center, but again, for the reasons I mentioned earlier, we may not have been able to reach them even within the simulation. In addition to all this, these philosophical leanings are also included in the subject. Of course, according to many traditional views in the Western world, humanity is the only intelligent being of divine creation. Those who support these views naturally oppose the idea that there could be intelligent life on other worlds. There are also conspiracy theories such as aliens are already among us but do not want to be noticed or are hidden by governments. In summary, although the possibility of extraterrestrial life or intelligent life is high, there are also many obstacles to our detection. There is also the fact that by doing this we may have brought about our end. Then one day we received radio signals that we saw. We decided to use our bodies as a powerful battery for our game consoles. We may encounter an alien worm coming in the form of a worm. I am Owl of Ages. See you in the next video. Take care. Goodbye.